All right, welcome back to another episode of Math with Mr. Young. Today we're going to be working with 7.3, Areas of Trapezoids and Kites. Our standard is 6th grade Geometry A, and our objective is that we're going to be able to find the areas of trapezoids, kites, and composite figures. Our mathematical literacy, we have Kite. All right, with 7.3, Areas of Trapezoids and Kites, our success criteria is that we're going to be able to find the area of a parallelogram and use that to find the area of a trapezoid. We're also going to decompose trapezoids and kites into smaller shapes and also use decomposition to find the area of a figure. Lastly, we're going to use the base and the height of a trapezoid to find its area. Our mathematical literacy, we have Kite, and a kite is a quadrilateral that has two pairs of adjacent sides with the same length and opposite sides with different lengths. Now let me go ahead and break up my protractor here, okay? So what I'm going to do is I'm going to go ahead and draw the y-axis, okay? And I'm also going to, let me zoom out just a hair. I'm also going to draw the x-axis. Okay. Now, when I go ahead and connect these lines, what we're going to have is a kite. So let me go ahead and do that real quick. And we all know that a kite, especially when it's windy, you know, it's a lot of fun to fly. So maybe we can hopefully do that when we get back in person. But there's a kite, okay? Now, let me flip this upside down. So what I want you to see is that you have with any triangle, you have a right angle there, a perfect 90 degrees, okay? Now we have 4 right triangles. A matter of fact, in this kite, you do have 4 triangles, okay? And this box here just represents that that's a perfect 90 degrees. Now, when we talk about adjacent, okay, let me just draw this here. I should have used my protractor. Okay, so if I look at this triangle here, okay, so this on the bottom would be called the opposite. The long side here would be called the hypotenuse. And this line here, where that 90 degrees is at, is called adjacent. Okay. And when we move into like higher mathematics, especially with trigonometry, you'll learn about more into this, okay? Now, this is a quadrilateral because it does have 4 edges. It has 1, 2, 3, 4 vertices. Also, it's a two-dimensional figure, so it has 1 face as well. Now, it does have 2 adjacent sides right here, okay? And then, you know, they have the same length, and we'll talk more into this as we go along. But let's have some fun. All right, with this example, we're going to find areas of trapezoids and kites. Now, our directions here tell us to find the area of each figure. So here, this geometrical shape is a trapezoid for problem A. And problem B, this is a picture of a kite. So let's focus on problem A here. Now, problem A, we have 2 bases. So the one at the bottom is 4 kilometers long. So that's base 1. And base 2 is way up top, and it is 9 kilometers across for base 2, sorry. And base 1 is 4 kilometers across. And our height here is going to be 5 kilometers, okay? So this trapezoid. Now what we want to do is we want to decompose this trapezoid into a triangle and also a rectangle. So we do want to find the sum of the areas of this figure, okay? So again, just to recap, our height, this is 5 kilometers tall, okay? And our base, this is going to be 9 kilometers across, but then you have 2 bases. So base 2 is 9 kilometers across, and base 1 is 4 kilometers across, okay? So again, what we want to do, I want you to know that since base 1 is 4 kilometers, then in here, we're going to have a rectangle, okay? So there is a rectangle in this trapezoid. So what we're going to do is we're going to take this piece here and we're going to connect it to the other triangle there. So it's going to look kind of like this, okay? And then because it's 5 kilometers tall, what we did was we just brought this right over. So this here, we cut it off with scissors and we just brought it over. So now you have that triangle there, and let's see, 4 and then 5. And then that rectangle again. This is 5 kilometers tall, and we have 4 kilometers across. This one we have 5 kilometers across and 5 kilometers tall. All right, so again, we decompose this trapezoid into a rectangle and a triangle, okay? Now we're gonna find the areas of these sums. Now in order to do that, you're gonna need to break out your, well, let me just cover this side for now. We're just gonna go ahead and break out our formula. Now the formula for the area of a triangle, so we're gonna find the area of a triangle. Let me just go ahead and flip this over and start again. It's all right, I made a mistake, but there we go. You know, you learn from them. So the area of a triangle is going to be area equals half base times the height, okay? And then we're going to add that to the area of a rectangle. That's going to be area equals base times height. Okay, now all we do here is we substitute the values for these variables. So let's start with the area of a rectangle. So the base here is 4 kilometers times the height, 5 kilometers. So 4 times 5 is going to be 20 kilometers squared. All right, that's going to be the area for this rectangle, 20 kilometers squared. And then again, we're going to have to substitute for this area of a triangle here. So again, your base is going to be 5 kilometers times your height, 5 kilometers. You just substitute those values in the variables or for your variables. Then you just multiply. 5 times 5 is 25 kilometers squared. And then again, you just multiply that by 0.5. So again, half of 25 is going to be 12.5 kilometers squared. And again, this is the area for a triangle. So this whole thing, this whole triangle right here is going to have an area of 12.5 kilometers squared. And the whole area for this rectangle is going to be area equals 20 kilometers squared, okay? Now what we're going to do is we're going to add those two areas together. So what we're going to have is area equals 12.5 plus 20. Now 12 times or plus 20 is going to be 32. So this whole thing is going to be 32 kilometers squared for the area of this trapezoid. Let me zoom out just a hair. Again, the area for this trapezoid here is going to be 32.5 kilometers squared equals the area. All right. So there you go. Again, what we had to do is we had to decompose that trapezoid. What that means is we had to break it into other figures. So this trapezoid, we broke it into a square and combined this triangle with the other triangle. And we had to find the area of the triangle and then the area of a rectangle and add them together to find the whole total value of the area of the trapezoid. All right. So we're going to do the same thing right over here when we find the area of this kite. Now with this kite, you do have 4 triangles. Here's 1 triangle, 2 triangles, 3 triangles, and 4 triangles. These boxes here indicate that this is going to be exactly 90 degrees. So it's going to be a right angle. Again, triangles and angles are different things. Okay, so you have 4 triangles and 4 right angles. Okay, now what we want to do is we want to pull this apart. We want to decompose it. Okay, so I'm going to pull that apart right now. So I'm just going to make them smaller. Okay, so we pulled this apart. So we pulled this kite apart, okay? Now, this here is 8 feet tall. 8 feet tall. Okay, this here is 3 feet. This here is 6 feet. All right, so again, you're gonna find the area of these two different triangles. So it's gonna be, let's break this out. We'll call this triangle 1 and triangle 2, okay? So for triangle 1, area equals half times base times height. So again, the base is 8 feet and the height is 3 feet. So half of 8 is going to be 4. Okay. And 4 times 3 is going to be 12. So the area for triangle 1 is going to be 12 feet squared. Okay. Now for triangle 2, again, area equals half times base times height. Okay. Now substitute the values. So again, the base is going to be 8 feet. The height is 6 feet. Okay. Now half of 8 feet is going to be 4 feet. And 4 times 6 is going to be 24. So 24 feet squared is going to be the area for triangle 2. All right. Now what you're going to do is add them together. So 12 feet plus 24 feet is going to be 30 feet squared is the area for this whole kite. Okay. So again, what we'll have to do to find the area of a kite is you're going to have to decompose that figure. You're going to have to decompose that kite into 2 triangles and then find the sum of the areas of a triangle. So again, we have triangle 1 and triangle 2. We just pulled that kite apart. Okay. We found the area for triangle 1 using the area formula, area equals half times base times height, and then doing the same thing for triangle 2. All right, that's really all there is to it. And again, add those 2 areas together to find the whole area of the kite. All right, moving on. So right here, we're going to find the area of trapezoids. So before we decompose the figures to find the area of different shapes, but this time we're just going to focus on the trapezoid. So if you look here, up top you have 5 feet, and down below you have 9 feet, and the height here is 6 feet. So again, you have base 1, you have 2 bases, and base 2 here. So base 1 is 5 feet, and base 2 is going to be 9 feet. The height again is 6 feet. So here's what we're going to do. We're going to have area equals half times the height. Okay, so here's the height. But since you have 2 bases, I'm going to put that inside parentheses. Base 1 plus base 2. Now this is the area formula for a trapezoid. Again, the area equals, just like a triangle, half times base times height. So it's exactly the same formula for a triangle. Area equals half times base times height. But you have 2 bases. Okay, so here's what we're going to do. So base 1, okay, is going to be 5 feet. And base 2 is going to be 9 feet. All right, so I'll leave that in parentheses. And your height is going to be 6 feet. Times half. So again, half times 6, like 0.5 times 6. Half of 6 is 3. Okay. And then all you have to do here is add. What's 9 plus 5? Well, 9 plus 5 is 14 feet. Now, I'm not squaring it because I'm adding. I only square it when I multiply, okay? Now, let's see here. Next, what we're going to have to do is just multiply. And let's see here. 14 times 3 is going to be 42 feet squared. Okay. Oops, I forgot to put feet here. So there you go. So the whole area of this trapezoid, inside the trapezoid, the whole area is going to be 42 square feet. Okay. Now we're going to do the same thing over here. So here's your first step. So write the formula. Step 2, we're going to substitute the values for the variables. Step 3, you're going to add inside the parentheses right here, base 1 plus base 2. And step 4, you're going to multiply. All right, again, the formula for the area of a trapezoid is going to be, write this down, area equals half, okay, area equals half times the height, and add base 1 plus base 2. All right, so again, in this case, base 1 will equal 8.5 meters, okay, for B. And base 2 is going to equal 11.5 meters. And your height is 5 meters. So we wrote the formula for step 1. Again, it's the area formula for a trapezoid is the same as the area formula for a triangle, okay? Except that you have 2 bases here. So again, area equals half times the height, which is 5 meters. We plug in the base 1 is going to be 8.5 meters plus base 2, 11.5 meters. Okay. Now 11.5 plus 8.5 will be 20 meters. All right. I'll just do this step by step. Now we're just going to go ahead and multiply. Okay. Now 20 times 5 is 100 meters squared. And we're going to multiply that times half. Half of 100 is going to be 50 meters squared. So this whole trapezoid is going to have an area of exactly 50 meters squared. All right, there you go. That's all there is to it. All right, we're going to continue. So right here, we do have a composite figure. And again, a composite figure is basically a figure that's made up of different shapes. So we're going to have to decompose it and break it into smaller shapes to separate this figure. And we want to separate it into a trapezoid and also into a rectangle. And then we want to identify the height of the trapezoid and then find the area of each shape. Okay, so right here, you can just put a line across and you have a trapezoid. So this is a trapezoid here. And this is a rectangle. So again, this rectangle is 4 inches across for your base, okay? Your height for the rectangle is 6 inches tall. Now your trapezoid, your base is 8 inches. And if you count the squares, your height is 2 inches, okay? Now again, the whole composite figure with both of these shapes is 8 inches long or 8 inches tall. So what we're going to need is the area of a rectangle and the area of a trapezoid. Let me move this over. All right. So the area of a rectangle is going to be area equals base times height. Okay. The area of a trapezoid is going to be area equals half times the height. And then having base, multiply that times the base 1 and base 2. All right. So here we go. Let's substitute the values for the rectangle. So the rectangle here has a base of, let's see here, a base of 4 inches and a height of 6 inches. Okay. 4 times 6 is going to equal 24. So this is 24 inches squared. That's the area for the rectangle right here, 24 inches squared. Now for the trapezoid, again, substitute the values in the formula. Again, the trapezoid height is going to be 2 inches. And then, of course, the first base here for this trapezoid, let's see here, is going to be 4 inches. Plus the second base is 8 inches. Okay, now 4 plus 8 is going to be 12 inches. Let me just bring everything else down. And then we just multiply. 2 times 12 is going to be 24 inches squared. And again, don't forget you have to multiply that times half. half times 24 is going to equal 12. So the area equals 12 inches squared. So you, my friends, found the area of the trapezoid and found the area of the rectangle. So the last thing we need to do is add these two areas together to get the area of this composite figure, okay? Now 24 plus 12, let's go ahead and add that together. 24 plus 12. Okay, so this is going to be 6 and 3. So 36 inches squared is the area for this entire composite figure. The trapezoid and the rectangle is 36 inches squared. All right, there you guys go. That's all you have to do. All right, the last problem we're going to work with is modeling real life. So before we talked about Arizona, and we talked about how many counties are in Arizona with a previous math problem. So in this case, we're going to be working with the state of Virginia, okay? Virginia is on the East Coast. So let's read the description here, the passage, the paragraph. So it reads as, you can use a trapezoid to approximate the shape of Scott County, Virginia. Okay, here's Scott County. The population is about 22,100 people. About how many people are there per square mile? So that's what we're going to figure out. So again, we can use a trapezoid. Here's Scott County. So the base 2 for Scott County is 38 miles, okay? Base 1, right here up top for Scott County, is 15 miles. And the height is going to be 20 miles. So we're just going to find the area of Scott County. And it does look like a trapezoid. We're just approximating, okay? So here we go. The first thing we do, we want to understand a problem. We're given the population of Scott County, and the population is 22,100 people, okay? And the dimensions of the county, the dimensions like the base, the height, okay, the length, the width, it's in the shape of a trapezoid. So we're going to use a trapezoid formula for that, all right? And we're asked to find the number of people per square miles. So we have to understand the problem. So we had to make a plan. Let's use the area formula of a trapezoid to find the area of Scott County. Then what we'll do is we'll divide the population by the area to find the number of people per square mile. So let's check it out. So the area of a trapezoid formula is going to be area equals half times the height, and then base 1 plus base 2. Okay, this is the area formula for a trapezoid. Make sure you write it down. Area formula of a trapezoid. Okay, area equals half times the height, and then multiply that to base 1 plus base 2. All right, so let's substitute here. So it says that our height is 20 miles. So area equals half times 20 miles. And then base 1 is 15 miles, and base 2 is 38 miles. So we just substitute 15 miles plus 38 miles. Then we just add, okay? So we wrote the formula of the area of a trapezoid, and then we substituted 20 miles for the height, 15 miles for base 1, and 38 miles for base 2. And then we add 15 plus 38 is going to be 53 miles. And then we multiply that times 20 miles and multiply that times half. Okay. So again, let's see here. 20 times 53, that will be 1,060. And when we multiply 1,060 times half, so half of 1,060 is going to be 530. So the area of Scott County is 530 square miles. But again, we have to do one more step, and that is to divide that by the number of people. So if we have, let's see here, 22,100 people, we're going to have to divide that by 530 square miles. Okay. So let me just go ahead and get my calculator. Let's see here. So 22,100 people is our population, and we divide that by 530 square miles. So we have 41, oops, let me do that one more time. 22,100 people divided by 530 square miles is going to be 41.69. We can round it up to 42. So we'll just say this is 42. So there are about 42 people per square mile. All right, there you guys go. And that's what we had to do. Again, we took it a step further because we had to find out how many people are, or how many people there is per square mile. All right. So that's what we're doing for 7.3 today, working with areas of trapezoids and kites. Our success criteria, by now, you should have a better idea about how to explain the area of a parallelogram and how that is used to find the area of a trapezoid. You should by now be able to decompose trapezoids and kites into smaller shapes, and also use decomposition to find the area of a figure, and to use the bases and the height of a trapezoid to find the area. All right, there you guys go. And again, please pay attention. I will do more examples with you guys right after this.